This topic is one of my favorites. It's called U substitution. It's a very common type of problem and way to solve an integral. If you retake this class in college, you'll certainly see this problem. All right, here's example 1. So we have x plus 2 raised to the 5th power. So what we do on U substitution is we choose something, and I'm going to tell you what it is on the first one, x plus 2, and we set it equal to u. And now I'm going to take the derivative of u, and that would give me du, right? Just because we take the derivative of x, that gives us dx. And now the derivative of x plus 2 is going to be a 1 and then a dx, because we're actually doing chain rule. We're taking the derivative of the inside function with respect to x. So what do I do here? I try to find a match. And I know this is kind of weird to start with, but I promise as we do many, many problems, you're going to start to get this. So this is going to be the integral, and instead of writing x plus 2, I'm going to write u, because I set u equal to x plus 2. So this is going to be u to the 5th. And then I want a 1 dx. Well, I can always put a 1 in the problem. That doesn't change anything. So I'm going to substitute 1 dx with du, because 1 dx and du are exactly the same. So I'm just going to write this as du. So now I can integrate this. That versus this seemed really complicated. So integrating u to the 5th is going to give us u to the 6 over 6 plus c. And then our last step is to go back, and instead of having this in terms of u, I know my u is x plus 2. So this would be x plus 2 to the 6th over 6 plus c. All right, let's go ahead and try another one. All right, on this one here, we're going to let u equal to 4x minus 1. And our derivative of u is going to be equal to 4, and then we're going to have a dx. All right, now I'm going to rewrite this as the integral of 4x minus 1 to the 1/2 dx. And so now I'm going to take u and replace it, because I know 4x minus 1 is equal to u. So this is going to be the integral of u to the 1/2. Now, I need to have a du here, but unfortunately I only have a dx. I want a 4 dx. Well, that's fine. I can put a 4 here, but that changes the problem, so I'd have to put a 1/4 out in front. So this is going to be this right here is now 4 dx, so this is going to change to a du, because I do have a match. 4 dx is a du. All right, at this point I can integrate, so this is going to give me u. We'll add 2 over 2 to this. It's a funky 2, huh? That gives me u to the 3/2, and then I'll have a 2/3. And don't forget about my 1/4 here, which I forgot to drop down. So my answer is going to be a 1 times 2, which is a 2u to the 3/2 over 12 plus c, which is equal to 1/6, or u to the 3/2 over 6 plus c. And we're almost done. All we have to do is take our 4x minus 1, plug it in here. This is going to be a 4x minus 1 over 6, and don't forget to raise this to the power of 3/2 plus c. There we go. Let's do another one. All right, on this particular one, this sounds like an integral we have no idea how to do. So we're going to get a lot better at figuring out what our u's are going to be. Sorry. But I'll tell you right now, it's going to be a 7x plus 5. Take the derivative of that, and I just get a 7 dx. So I can rewrite this integral as the cosine of, that's going to become u, and I want to be able to replace this as a du, but unfortunately it's just a dx, and I want a 7 dx, so I'm going to sneak a 7 in there, which means I have to put a 1/7 on the outside. Now my 7 dx can become a du, and now this is something I can integrate. So the integral of a cosine u du is going to be sine of u plus c, and do not forget to bring your 1/7 down. All right, last step is to go ahead and replace your u with in terms of x. So this is going to be a 1/7 sine of 7x plus 5, and then go ahead and remember your plus c. All right, let's do another one. In this particular problem, I'm going to let u be equal to x cubed. So du is going to be equal to a 3x squared dx. So I actually have an x squared dx, so that I've got a match there, but I need to have another 3. So I'm going to have a 1/3 that I need to put on the outside because I just put this 3 in the problem. So now everything I've underlined here, an x squared, 3, and a dx, that's a perfect match here, so I can replace that with a du. So this is a 1/3 here, and this is going to be a sine of u. Now you're saying, where did everything go? Well, these 3 things that I circled in red, that became a du because it was a perfect match with this. Now the integral of sine u is going to be a negative cosine of u, and don't forget about my 1/3, so I can write this as a negative 1/3 cosine u plus c. All right, and remember, because computer science is bad, so that would be a negative. That's why I need to have the negative here. And the last step is going to be to put in my x cubed in for u. So I get a negative 1/3 cosine of x cubed plus c. All right, we definitely have another video coming with more problems, so do not fret. This will be a long topic that we spend quite a bit of time on in class. Thanks for watching.